Running your LiPo battery packs in parallel, 2, 3, or even 4 or more packs in parallel is a great way to extend your range without having to buy larger battery packs. The advantages of using packs in parallel are that there's often a price point with any given brand or line of batteries, in which case the per amp hour price is beneficial. The 2.2 amp hour or 2200 milliamp hour packs that you see here, that basically every manufacturer makes some version of this in 3-cell, tend to be a very economical battery. Beyond that, the price tends to go up when you get to the 4 amp hour, 5 amp hour. This is a 4.5 amp hour, and so you pay more per amp hour. So sometimes it's beneficial just to use more smaller packs up to a point. Another potential advantage of this approach is you can have potentially one pack size but many separate packs for planes of different size in your fleet. You may have a smallish plane you can use one pack for, 2.2 amp hour. An example might be the noob tube or the axon. Then you can add a 2 parallel connector and use 2 packs, like say the Synapse, or you can use a 3 connector and 3 packs in parallel, like the Ainsley Peace Drone, and then just switch connectors as needed in between, but still only rely on one pack size for your whole fleet. It is critically important that each of your packs has the same cell count. These are 3-cell packs, and though it's theoretically possible to run packs of different size with the same relative internal resistance, it's really best practice to stick to the exact same pack size and purchase these packs at the same time, charge and balance them to the same state of charge, and check the internal resistance from time to time to ensure that one pack doesn't over discharge relative to its partners. In this video I'll show you how to make the connectors using XT60 connectors to connect 2, 3, or 4 packs in parallel. To use your LiPo packs in parallel, you will need to buy or make these parallel connectors. Additionally, there's a choice as to whether you want your multiple connector attached to a lead permanently like this, or whether you simply want to have an adapter like this that you'll need to attach an extension to. If you have a plane that you are certain you're going to be flying the same configuration always, you can eliminate one additional connector by soldering on your multiple parallel connector like this. Whereas if you feel like you'll potentially need to switch out maybe 2 4 amp hour packs sometimes, or 4 2.2 amp hour packs the other time, it's nice to have these separate connectors that you can install only as needed. The side plugging type like this is much easier to solder, as you can simply lay the wire over the top of all the terminals and solder it down, but this does of course create the potential for a large bundle of wires protruding sideways as you plug in the batteries here. So if you have a narrow space or a narrow internal fuselage, this may cause a sort of a cumbersome bunch of wires protruding out this side of the connector. The end connector style is a little harder to solder, particularly the 3 and up, but it does provide a nice narrow streamlined connector situation where all the wires are parallel to one another, so it can fit in a very narrow slim space. Personally, I strongly prefer XT60 connectors for a multitude of reasons. One is the sides, as you'll see, are parallel to one another, so that they can be ganged together side by side in many multiples without any difficulty at all. Additionally, this nylon connector material is very heat resistant and tends not to deform when you are soldering, and as well when you apply any heat shrink tubing like this, it tends to maintain its shape very well. Also, the terminals are very easily accessible here and quite easy to solder. Dean's connectors, as you'll see, do not have parallel sides. Therefore, although it's possible, it's more difficult to stack these side to side and still have them parallel to one another. EC type connectors are somewhat difficult to accomplish this with. There's only a very little bit of material here with which to glue them together. Most commonly you'll be joining multiple male connectors, so you can join multiple batteries in parallel, but the same applies if you want to have one battery as your source for multiple devices. Now note the terminology here. Although this plastic receptacle would appear to be the female, the conductors inside are actually male, as they go inside the female conductors on this side of the battery. The first step is to take your 2, 3, or 4 conductors like this and attach them to one another even before soldering. This can be accomplished by holding each connector applying some CA or similar glue, and then by manually sticking them together, keeping the edges perfectly parallel and aligned like this. A relatively foolproof alternative to this is to clamp the connectors together like with this squeeze clamp, and then apply some thin CA glue to this crevice right here, and let it run down in between the connectors, and then hold them together. Once this application of CA glue has hardened, I will turn these connectors over and reapply the CA glue to the opposite junction to make a really firm joint. Once the connectors have been securely glued together, it's now time to solder the terminals together in parallel. If you have a 2-into-1 parallel connector, it's usually just as easy to apply the end technique. This doesn't require any wire at all. You simply take the opposing female connector here and then solder it back to back with the terminals like this, taking very careful care to ensure that you have the positives all aligned and the negative terminals all aligned here. They're helped by the fact that the connector is shaped with a sort of a tapered end here at the negative and a flat end for the positive. For the end-to-end wireless terminal-to-terminal soldering technique, the most delicate step here is to get the first solder joint applied. So these need to be held end-to-end with the polarity correct. That's negative on this end, positive on the other. Helping hands for soldering work fine. I'm just using a piece of removable masking tape and setting it on my work surface, so I can apply just a small amount of solder to set these together before I apply the solder in earnest. So by heating any two of the terminals and applying just a tiny bit of solder, you can get them stuck together. After that, it's smooth sailing. Once you've got that first little solder joint applied, you can easily handle this as a unitary piece. At this stage, it's not a bad idea to install a corresponding connector to each of the females and males, just to help hold the plastic from conforming where it actually holds the terminals in place internally. The XT60 connectors use a really nice high temperature plastic, so it's really rare for it to deform, but if you have some spare ones laying around, it's good practice. Now I will apply some flux and put a really strong solder joint across the terminals, and then flip again and apply a strong solder joint to the opposite terminals. Once both sides of terminals have been securely soldered, sight down between the terminals and be absolutely certain that these are not shorted together. As you can see, no bridging solder between those two sets of terminals. Here's an example of one where the solder did bridge through the terminals, and therefore you cannot see any light through there. You cannot probe between, and I can't verify that this wouldn't short out the first time it's plugged in. For the 3 and 4 connector, I usually try and get away with the side terminal type, just because it's much easier to solder. And you can use either stranded wire like this, 14 AWG, from silicone wire from Hobby King. It's stranded and it's not hard to work with, but the trick is to keep those strands tightly twisted together until it's soldered together. And this will be soldered across the terminals, similar to this. What I actually really prefer to use is single strand wire like this Romex 14 AWG or similar wire. It's easily acquired from a hardware store, Lowe's, Home Depot. It's easier to work with, takes a lot less solder, and is easier in that it doesn't unravel because it's not stranded. Now, while it's not critical, it really does make it easier to solder if you apply some electrical solder to the wires and the terminals. I'll be soldering the single female connector, which goes to the ESC, to the multiple already glued together male connectors on this end, using intervening pieces of, I'm using the 14 AWG single stranded wire. You can also use actual stranded wire like this. The principle is the same. And as to whether you want to go from the end like this with a connector like that, or straight out the end like this, this can simply be bent to accomplish the same effect of coming out the end, or these strands can even be pulled apart and splayed out like this, so you have a sort of a T-type configuration with an additional conductor protruding out this direction like this. Plug in the opposing female terminals into the terminals we're going to solder together, and then pre-tin at least one set of terminals, so one negative and one positive. It doesn't hurt to go ahead and pre-tin all of them, but for the tacking solder to install the conductor first, Now take your conductor, whether stranded or single conductor, sanded and or flux applied, ideally both, and then I've pre-tinned the tip of that as well. So what I'll do now is just seat that across all of these terminals here, and then just tack it in place with this one. That will hold that particular conductor in place across all of the negative terminals, so you can go back and solder each of those individually, and then finish up by going back to this one that you've just pre-tacked. I'll repeat that on the opposite side for the positive terminals. There's a million ways to hold these connectors while you solder them. One is a vice grip like this, gently applied, not to crush and deform the connectors. Another are some pliers with a rubber band around the handles just to hold that connector in place while we do the soldering. Once the companion terminals are already solidified and soldered, you can go back and bolster up the tacking solder there. Inspect your solder joints to ensure that you have solder bridging both sides of the main conductor here, so across the top and then down in this area as well. That'll be nice and strong and secure. And then the most important of all is be sure that there are no bridging solder between the two terminals, positive and negative, that would short out your battery. Additionally, try to be sure that there aren't any sharp little spikes of solder protruding up or to the sides, so that when you apply your hot glue or epoxy or whatever, it will not tend to wear itself out in such a way that it will protrude and cause a potential for a short. So these are nice and smooth all the way around. The next step is to solder on the connector that will accept the extension to the ESC or the ESC directly, and so we'll trim off these conductors here. You'll see that this doesn't seat very far down in there, about 4 millimeters at most, and so these can be trimmed off pretty tightly so that this can be soldered here. Now that bus bar connector has been trimmed back to accept the ESC connector so that the terminals just touch right here and here. This will provide a very strong solder joint. When in soldering these, of course, be absolutely certain you get positive to positive and negative to negative, not the other way around. Just make a light tack joint there, and then you can sort of finalize up the angle. If you wish to have that come off exactly 90 degrees, you can bend that slightly into place. Then I'll come and put a true solder joint on this side, and then the third step, of course, is to go back and finalize that solder joint. The final step is to apply some hot glue, epoxy, or whatever substance you like between each of these terminals to prevent shorting out, as well as to provide a tiny bit of extra structural integrity. I like this black nylon hot glue. It just hardens more durably, I think, than the clear stuff, but anything works. And you do pretty much what you think you do, is just kind of squirt it in and around there and let it harden in layers. And if you're very particular, like I am, you can sort of smooth this out either with a heat gun, or you can just sort of mold it with a cigarette lighter, keep it liquid, keep it flowing around until it conforms nicely the way you like. Flows all down in there. So however you decide to do it, once it's nice and cool, very carefully inspect that to be sure no pieces of solder or wire are protruding through the insulating glue or epoxy like that, and then you're otherwise ready to go use it.